Okay. So in last session, so we were talking about the SQL operating system, how threads and scheduling works, right? Um, yeah. So in a high level, I mean, I understand, right? Last time I was in between in a call or something. So high level, I will so explain like what is that, and then we will go with further. Okay. So here we have a SQL operating system. Okay, um, all right. So we have a SQL operating system where it manages SQL layer. So we manage the scheduling, right? So instead of allow Windows to schedule our threads, and we are managing our own threads so that the threads will not be preempted, right? Um, Right. So the threads will not be preempted on its own, right? So we manage our own threads so that the threads will not be preempted. So right. So there are different reasons when the thread will be preempted, right? One, if there is a high priority thread comes in, so the thread will get out of the CPU and will allow other thread to execute. Second one, if quantum is completed, quantum slice is completed. So what is the quantum value here? Like 4 milliseconds. 4 milliseconds is at the Windows level. So whenever the thread is completed is 4 milliseconds, the thread will go out of CPU. I mean, out of CPU as in like the kernel level, the thread will go out of CPU. 1 second. Right? So thread will go out of CPU and it will allow other thread to execute. Ha- Um, let's say this is your SQL layer and it is your kernel, right? So CPU at the kernel, I mean CPU at the kernel level or Windows operating system will be one-to-one mapping with the logical layer at the SQL layer, right? So logical uh, kind of, so CPUs. So what we call it as schedulers. Okay. So these are SQL schedulers. These we call it as a CPUs. Okay. Or processors, right? Processor is nothing but, so the process is executing on individual container. Processor is nothing but a container or individual CPU. We call it as a processor in SQL or in terminology, right? So Windows operating system, we call it as individual processor. If you go to the task manager and you see that logical processors, right? So where the process is actually executes its threads, right? Process is nothing but an application installed on the computer, right? So process itself will not execute any of your work, right? So who executes the work as a thread? A thread is a minimum unit, like a small um, like a work is nothing. I mean, thread is nothing but a worker which actually takes care or executes your workload, right? So that is the thread. I mean, just I'm covering, like we all discussed these details, right? So these two are including, I mean, these two are mapping one to one, right? So schedulers is a logical, whereas CPUs are physical cores, right? So on the system where it maps one to one. Whatever threads coming in, right? So let's say, for example, you have 514 threads, right? So for example, just I'm taking an example. Based on number of CPUs, this threads calculation will be differ. So we will talk that, so max worker threads later, but the number of based on number of CPUs. For example, let's say if you have 4 CPUs, then a max number of workers, right? Maximum workers. Remember, maximum workers. I'm not talking about the concurrent workers. Concurrent is nothing but at the same time, how many threads are executing is different. So these are all maximum workers. It is. I mean, so in other way, like so 514 maximum concurrent workers at any given point of time. So I can consider I'll just put in this way, right? So 514 or whatever the threads, maximum how many threads it executes on the server, right? So 514 as the maximum concurrent threads. At the same time, how many threads can execute it, right? So if it is 8 CPUs, the calculation would be different, right? So we will talk that later. For now, understand you have these many threads, right? So if there is no Windows, if there is no SQL operating system, no SQL OS, then all threads will spawn, right? So all threads will be spawning, right? So all threads will spawn and so on it will wait on the Windows operating system. Let's say how this will be distributed. This will be distributed across 3 CPUs, right? For 514, it will be round robin. It will be distributed on this, right? So for example, let's say 170, 170, 170. Just an example. So I have these many threads. What if you don't have a SQL operating system? All threads will try to execute one by one, right? So one thread, once it is completed, it will go and it will wait in the run. It will wait in the kernel or Windows level after 4 milliseconds quantum slice, right? So, and in this Windows operating system, there are chances some other applications you have, right? So let's say, for example, any high priority application or high priority thread, right? So not only SQL thread, right? It is a Windows level, kernel level, right? You can have any other application threads also. So all will be in the same CPU scheduled, right? So if some other application has the highest priority, whatever thread which is currently executing on the CPU will be kicked out of the CPU and it will allow other thread to execute on the CPU, right? So that we don't want. So that is the reason. So SQL layer, we are throttling the number of threads. We are controlling the number of threads, right? So how we are controlling? At any given point of time, we'll be sending only one thread at a point of time to the operating system, right? So only one thread will execute on the system, on the CPU kernel level, and we don't even so we don't have a different um, priority levels. We all have the same priority levels, right? So whatever 500 threads, so all are on the same priority levels, right? So it will not have different priority threads. So the main reason that we have, it is a non-preemptive. So non-preemptive. So non-preemptive is nothing but, so the thread which is executing on this. So since it doesn't follow the priority, the thread will not go out of the CPU, right? So the thread will not go out of the CPU because of the different priority level, right? So the second thing, the thread which is currently executing will not go out of CPU to the SQL layer as soon as it completes 4 milliseconds. So what it happens actually, 4 milliseconds is the Windows level quantum, right? So what I mean, so this is at the operating system level. So it will not, after 4 milliseconds, it will go back to the SQL. No, So 4 milliseconds is a quantum. It will go out of the CPU and checks if any other threads which are in the CPU. Then again that query, that the thread will execute. It checks if there is any thread. If there is a thread, it will allow other thread to execute. If there is no thread, if there are no threads, then the same query, the same thread will spin and execute on the CPU, right? Second reason that we have SQL level operating system is to reduce the context switches, right? So what is context switching? If it is switching every 4 milliseconds, right? So come out of CPU, like it will come out of CPU, and whatever the state the thread was, right? It has to load that state into some uh, somewhere, right? So because whenever it has to load again, it should not start from the beginning. So it will have to load again, whatever the state or register point, then it will start executing on the CPU, right? So like, so every 4 milliseconds, it will have to load the context, and it will have to unload the context, right? Register the context and load the context, register and load the context, right? So if that is the case, then you will have a high context switches, and what will happen due to this, you will see high CPU utilization, right? So we are reducing the context switches. Subsequently, we are reducing the CPU utilization, right? So CPU utilization. Third, we call this as a cooperating system. Cooperating system. So what is cooperating, right? For example, let's say the thread currently executing on the CPU, right? So let's say thread 1 is executing on CPU. Thread 1 is executing on the CPU. This thread 1 is needs some what we call uh, it needs some resources, right? Let's say, for example, it needs some lock, or it needs some page, right? It has to wait, or it requires some anything, any wait resource, any resource it requires, right? Page, memory, or IO completion, or anything, right? It requires some resource, right? So if it requires some resources, it doesn't make any sense to spin on the CPU because it needs some resources. If it keeps spinning on the CPU, how it gets the resource, right? So it doesn't. I mean, it will not get the resource if it is keep spinning the on the CPU, because when we spin on the CPU, if we have all the resources which are required, right? If I need anything, it should go out of the CPU, right? It will go out of the CPU, and it will allow other threads on the SQL layer to execute on the CPU, right? So what before it leaving, so what it does, this thread 1, it gives a signal. It gives a signal to the thread which is currently waiting on this waiting in the scheduler. SQL OS level, it will give a signal stating that I am coming out of CPU, be ready to execute on the CPU, right? It will respond to the signal, and it will go ahead and execute the thread on the CPU, right? So it will go ahead and execute. So that is what we call it as cooperating system. It will be cooperating with each other, right? So the threads will be running on the CPU, and the thread is waiting on the waiting for CPU. It will give a signal so that the thread will be going and execute on the CPU, right? So the thread will go ahead and execute on the CPU. So that is what we call it as a cooperating system. So you can find the signaling here, right? So for example, select start from sys.dm OS. I'll give, we have DM queries as well, so I'll give that, right? So if you see here, signal wait type, right? So you all can see the font, right? It will have to. mm, Okay. Right. And if you see here, so sys.dm voice wait stat. So what is this DMV and what we get? So we'll talk that later. For now, just understand that there is a column called signal wait time. So this will tell how much time it is waiting for the to signal to the thread which is currently waiting, right? So it can be anything. So I will talk, right? So this is what we call it as a signal wait time. Yeah, what is this? Right. So this is what we call it as a signal wait time. If it is waiting for signal, right? So in SQL operating system, so or even right, so we have a different queues, right? So if you go back here, we were talking, right? So we have a different queues on each scheduler, right? Um, you can consider this is a different schedulers. We have the Windows operating system here, right? So you can, so different queues are, we have, what are all queues that we have? We have runnable, waiter, list, timer, IO, thread pool, what, right? So we have different queues. Hmm. IO request, timer, worker queue. Yeah, so worker queue, or you can consider that as a thread pool or worker, right? So worker queue. So where you'll have this available workers and it will pick up the task and execute on the CPU, right? So whatever threads which are currently executing on the CPU. So this is what we call it as a running. The state is running, the thread, right? So if a thread is waiting on the CPU, right? So I mean, waiting on the schedule, waiting in scheduler SQL layer and ready to run on the CPU, right? It is available. So it has all the resources and it is available. So I told you, right? At any given point of time, only one thread will go ahead and run on the CPU. So since you have 500 threads, even SQL layer, operating system layer, the threads will be distributed equally. For example, if it is 540 or whatever it is, so it will be equally distributed in a round robin fashion at the SQL level as well, right? So at any given point of time, only one thread will execute. Suppose if you have 170, only one thread executes. Here also one thread, here also one thread, right? So at any given point of time, these are the three threads will go ahead and execute on the CPU, right? So remaining threads will be waiting, right? So it depends on what which queue it is waiting for, right? For example, all 170 threads or 169 threads doesn't have it doesn't doesn't require any resources, right? All are waiting for the CPU to be available. Then it will be in the runnable queue, right? So you can consider that the runnable queue, right? If threads are ready to run on the CPU, so we consider it as a runnable queue. So runnable queue, and if the thread is in the runnable queue, the state of the thread will be in runnable, right? So the state of the thread will be in runnable, right? So runnable as in, like, for example, if you execute select start from sys dot, these DMVs, don't worry, I'll explain. These are all just basic DMVs that I'm executing. Requests. Right, so you can see, I'll show you one of the sessions. Fine. Um, uh, for example, you take this, right? So this is just I'm showing here because it says that runnable. Uh, this is runnable, right? So runnable is nothing but it is ready, right? So you are not waiting for anything. You are ready to run on the CPU. So it will be on the runnable queue. Let's say you have to wait for some resources, right? So this thread requires some resources. It will give a signal to the thread which is in runnable queue, so that runnable queue thread will be responding to that signal and will go ahead and execute on the CPU. And this thread, if it requires some resources, it will not go back to the runnable queue. It will go back to the waiter queue. It will go back to the waiter queue and it will be waiting for some resources, right? Until the until the resource it acquires, right? So until the resource it acquires. As soon as the resource it got the resource, right? Whatever waiting for, let's say lock, memory, whatever it is waiting for, it receives that resource, right? It got the resource. Then it immediately it will not go ahead and run on the CPU. It will not, right? So it will go back to the end of the runnable queue and will wait for its turn, right? It will go back to the end of the runnable queue and it will wait for its turn to execute, right? What is runnable queue? Runnable queue, it don't have any, it is not waiting for any resources. It got all the resources it requires and waiting for CPU to be available, right? So it means there is a currently one thread is executing on the CPU, and the thread which is in the runnable queue, it has to wait for this thread to give signal, right? Until that thread gives signal, it has to wait for its turn. Likewise, we have something called timer list, right? Supposedly there are some scheduling threads, checkpoint, lazy writer, or resource monitor. Like there are internal threads we frequently executes, right? Every 5 seconds or every 1 minute is it wakes up and execute, right? So those are also the same process it has to follow, right? So I'll just show you here, right? For understand, right? It is a normal priority runnable queue. So runnable queue I mentioned because it is ready to wait for CPU to be available. So there is a thread currently executing on the CPU, right? So someone is executing, some thread is executing on the CPU, and we have different workers, different queues, right? So we have a worker pool, we have a waited list, we have a timer, we have a IO, like different lists that we have. Suppose, for example, the thread which is coming out of CPU, right? So if it come out of CPU, it will not immediately go, I mean, if it comes out of CPU, right? So it will be in the end of the runnable queue. So whatever reason, if it go out of CPU and it should go out end of the runnable queue, right? So immediately it will not wait, right? If I go here, uh, right, it will go out at the end of the runnable queue and first in the list of the runnable queue, it will go ahead and execute on the CPU, right? Next one, if I, so if any of the IO thread is waiting, if the thread is waiting for IO to be completed and the IO is posted, IO is completed, then it has to go and execute on the CPU, right? So as soon it requested IO, right? So what we call it as a asynchronous IO, and the IO requested has been completed and the query has to be completed. The query has to be executed. What it was waiting for IO. IO has been completed. Then the thread has to go back and execute on the CPU, right? So that is what it is. So it will not immediately go ahead and execute on the CPU. It will be in the queue, runnable queue, end of the runnable queue, right? Next one is timer, right? So the same thing, it will be at the end of the runnable queue and waited list also will be end of the runnable queue and wait for its turn to execute on the CPU, right? So these are all it, these are the queues that we have, right? These are the thread states, right? So what are the thread states that we have? For example, if you see that sleeping is a majority, right? So we might see many times if the thread is currently in sleeping. So if the thread is currently in sleeping, so the execution is completed, right? So whatever query that is executing is completed and not close the connection. The connection has not been closed, right? The connection has not been closed. So that is where we see that it is showing a sleeping connection. Suspended if the thread is waiting for some resources, right? I told you if in the waiter queue, if the thread is required some resources, either it can be a lock or it can be memory, it can be, so anything that it is requires some resources, right? It will be in the suspended state. And pending is basically like we don't have a thread available, right? So we don't have any threads available and CPU also not available, right? So the thread. So I don't think you see pending as a status, right? If the thread is not available, so you would not be able to see that information eh, connected to the SQL, right? So you don't see that. This is just for your information. So I mentioned here. Runnable, the thread is not waiting for anything. It is ready and waiting for CPU cycle, right? Waiting for CPU to be available. I have a thread, but no CPU, right? CPU is not available because some other thread is currently running. And if you see here, the status is running. The thread is currently running on the CPU itself, right? If the thread is currently running on the CPU, the status is running. So remember, only this point, only if the thread is currently executing on the CPU, the thread is actually consuming CPU, right? So the thread is actually consuming CPU. If it is waiting for some resources or if it is in the runnable queue, so or I mean, like if it is not running on the CPU. If it is not running, then the thread would not be consuming CPU or it would not be a high CPU consuming query. So that is what it is, right? So this is a high level flow chart that we have. So whatever incoming request that we have, right? So we got a request, we have a request from the user, and it checks that whether we have an idle worker available or not, right? So we'll see that it checks whether an available worker exists. We have an idle worker. Idle worker is nothing but uh, thread is completed its execution, it will go back to the queue, right? So that is considered as an idle, right? So the thread is not waiting for anything. The thread is not in the um, state of executing. It is waiting for a task to be assigned, right? So then the thread is available. So if the thread is available, assign the request to the idle worker and it will be placed into the runnable queue, right? So again, the queries will not go ahead and execute on the CPU. It will always go back to the runnable queue, right? So then if the thread is not available, so there is no idle thread, right? So it will validate whether the worker's limit has reached. I was talking about 514 or whatever the number of workers, right? 540, whatever the value, right? It checks that worker limit has reached. Whatever tasks that we have, all are concurrently assigned threads, right? So if worker threads are not reached, if the worker threads are not reached, then it will go ahead and create a new worker and assign that to the request, right? So worker is nothing but in SQL terminology, we call it as a thread, right? So worker is a Windows terminology that we use, but it is considered as a thread, right? So worker or thread, both are same. Worker is a SQL word, a SQL terminology, we call it as a thread, and Windows terminology, we call it as a worker, right? It checks that worker limit has reached. If not, create a new worker and assign that worker to a assign that request to the worker, right? If it is reached, it will be in the queue to be queue worker request queue. So to available an available worker, right? So that is where we see this pending. I was talking, right? So if you don't have a worker, the thread has to wait for an available worker to be assigned, right? So this is what we discussed, right? So hope it is clear. Like if you have any questions, you can ask me, or if you don't, I will go forward. Right. So let's move on. We'll talk. This is a high level, like what we have, right? How we define the performance tuning, right? So how we define the performance tuning. So basically, performance tuning, I consider two things. I mean, uh, as in like one is general performance, right? Second one is query tuning, query performance. That's it. So at any point of time, application says that there is an issue, right? So if there is a performance issues, we'll have to consider one of these two, right? So either it is a general or it is query level performance issues, right? What are all questions that we ask, right? So we need to understand either it is a query performance or any specific query is taking time, or it's a overall system that they have the performance issues, right? Based on that, we further narrow down and troubleshoot the issue, right? So the same thing that we have here, right? Performance issues. Performance issues. So we check like if there is any specific query is running slow or not. If there is no specific issue, so we'll have to see the configuration wide any issues, right? So I will talk the configurations now, right? So whatever the basic configurations that we have, and we'll have to make sure that these are all following the basic configurations, right? So if there is any configuration wide issues, right? If there is no configuration issues, then if there is no specific query, right? So not a specific query, and there is no issue with the configuration, then you will have to go ahead and check the complete server wide performance issues, right? Let's say, for example, CPU, memory, IO, it could be network, right? So anything at the server level that needs to be validated. So if it is a configuration issue, right? So it should be yes here. If it is a configuration issue, then reconfigure or correct the configuration, right? So it can be anything. Let's say, for example, max degree of parallelism, or it can be a memory, it can be any configuration. It matters, right? So whatever it is, and we'll have to recorrect those configuration issues. Let's say application says I have a specific query which is running slow, right? So if the specific query is an issue, right? So we no need to validate the configuration, right? If there is a configuration issue, a specific query would not be slowing down, right? So there could, I mean, there are chances, but very less chances it can be slowing down because of the configuration. Let's say, for example, they have 10 queries, 10 queries, out of which one is running slow. Out of 10, so only one query, then there are very less chances that the configuration is an issue. If there is an issue at the configuration, server wide configuration or database wide configuration, so all the queries would impact it, right? Not only a specific query. If that is the case, we'll have to see if the query is identified, right? If the query is identified, let's say, for example, they mentioned that there is a click that is running slow, right? So there is a click, like they have an application where they are doing some click, right? So, or if you go to application, for example, Amazon, right? So if you click on some product, it is taking time. So that is just a so symptom, right? So it is taking time. But what is taking time? So either it is an issue with the SQL, or it can be anything. That is different story that we will have to investigate from the SQL Server side. So we'll have to see whether the query is identified or not, right? If the query is identified, then we'll have to see the specific query performance, right? Execution plans, like whatever, like either that query wide, we'll have to uh, further checking, right? We will talk about the query performance later, right? So if the query is not identified, right? So if we cannot find, if the query is not identified, we'll have to detect, or we'll have to determine the query is running slow, right? Or there are chances, right? For example, let's say they mentioned that stored procedure is slow. So inside the stored procedure, there can be hundreds of queries, or 10, like bunch of queries that we have in the stored procedure. So we don't know which one is running slow, right? So the stored procedure is kind of anything, right? So the stored procedure has this insert, update, delete, select, whatever the queries that we have. We don't know which query is running slow, right? So during the time of execution, we may have to capture some kind of traces. It can be DMVs, it can be extended events, or it can be profiler, or even it can be query store, right? So we will talk that query store later in one of the sessions, right? Uh, and we'll talk about the extended events, DMVs, profiler as well, right? So we'll have to capture the query to identify the specific query, then we'll go ahead and check the query tuning further, right? So this is how the high level performance cost map, right? So let's move on with the a few configurations which might be helpful, right? So there are few configurations, right? It might be outdated. For example, let's say I have a latest version of SQL Server, right? So 2019 or 2017 or even 2022, right? So some configurations might not be required, right? For example, let's say trace flags that we mentioned here, right? So might not be required, right? Because these are all inbuilt feature in latest version of SQL Server 20 starting from 2016, right? But still I mentioned to worth note so that it will be like people are might be using the older versions. It might be helpful, right? Or even new versions. What are the added features also you will get to know one second. For example, hardware or operating system considerations, right? So when you have the new system or when you have a server, so the main important things are the hardware, definitely, right? Because if you have a two CPUs, for example, and you have hundreds of user connected and keep executing on the CPU, right? So I have noticed personally, so I'll tell you, so let's say you have only two CPUs, two CPUs, or two, just an example, you can consider that even four, eight, whatever it is, right? So four CPUs I have, and I see always I have a high CPU utilization, high CPU, right? We are going, this is not the CPU kind of, so session. So we will talk this in detail, like I will show you and how to check and what needs to be validated. This is just an example I'm talking, right? So in terms of hardware resources, I'm just considering only that point, right? Let's say you have high CPU utilization almost every day, every minute, I see 100% CPU utilization, right? So and you are checking that high CPU consuming queries and you don't see any long running query, right? So you don't see any long running queries, right? So none of the queries are executing within uh, 10 seconds or even not more than a few seconds, right? So 20, 30 seconds. It is none of the queries are executing more than 20, 30 seconds, right? So if that is the case, and I'm wondering like why CPU is spiking up, right? So what happens, let's say for example, hundreds of users connected and executing at the same time, right? So what happens? The CPU is very busy in accepting the connections and proceed with the executions, right? So let's say you have four CPUs, this 100 or let's say 100 connections or queries executing at the same time. So each CPU will have 25 threads, right? At any given point of time, 25. And this thread executes, and as soon as it's completed, as I said, right, it is just a few seconds and it go out of the CPU, and next immediately another query, immediately another query. So it's a very busy system which executes very frequent executions, right? So frequently executing, and this is very busy system, right? You have high number of so connections, and which has high number of threads. I mean high workload you have, and because of that the threads is keep executing even if you don't see that high CPU intensive queries. And if you have a high workload or if you have a high number of connections, then the CPU will be pegged up, right? So the you will see that high CPU utilization because of high number of connections or the workload, right? So number of cores based on the workload, right? So memory configuration. So this is also important, the memory configurations, right? So let's say, This is your SQL Server, right? So we allocate memory to SQL Server, right? So we allocate memory. By default, it is allocated some a random value, right? So it's around whatever the petabyte that we have. So basically, it is taking the bigger value. I think I have configured, but let's see. So I have configured, but by default, it will be some hues in petabyte, right? So around 200 or something petabyte, it will be allocated to the SQL Server, right? So what will happen if you don't have a proper memory configurations or if you don't have a memory? One sec. I have added. Okay. So you don't have a memory configured. Let's say, for example, your queries, whatever queries that you are executing, it needs more memory. Let's say, for example, I have for 10 GB of memory on the system, Windows operating system. So for SQL Server, you have allocated some memory, or even if you leave that memory, if you leave that whatever default I was talking, right, 200 or 2 TB, 2 petabyte memory that is by default. So that memory, if you leave that, and what happens to the some other applications which requires more memory, right? So that is the reason you will have to have a dedicated system for SQL Server so that the memory or the resources will not be shared, right? So the resources, let's say you have only 10 GB of memory to the system, operating system. This 10 GB, so especially a heavy, applications, let's say SQL Server, and you have something called Power BI, right, for reporting. And if you have any intensive applications, if you install on the same computer, then what will happen? This memory would not be sufficient, right? So you will have to have a high memory on the system to maintain the workload, to handle the workload, right? First thing, you should have a dedicated system. So it is not recommended to have multiple applications on the same computer, but there are some um, customers, or there are some uh, users are still using the same computer to reduce the cost or whatever for the operating system, right? So they are still using same computer. For that, so you'll have to have the proper memory configured, or some other systems, you will have multiple SQL instances, right? You can have maximum 51 instances on the same computer, right? So you have multiple instances on the same computer, and but you are using the some memory, random memory. Let's say, for example, 100 GB of memory that you have on the system, and you have multiple instances on the computer. Then the memory has to be distributed equally. So the memory configuration on the system is important, right? So this is the memory. I will talk about the max memory and min memory that we have in a bit, but for now, understand this is the hardware requirement. So I need some amount of memory I required, and it should be enough memory to handle the workload, right? And disk subsystem, obviously, right? So if the disk is bad, your entire system will go wrong, right? So the entire system will go, will be impacted. So in other words, right? So if the disk is bad, there are chances your application workload will be reduced. It doesn't matter, right? Either it can be a CPU issue or memory issue, but if the storage is not optimal, this can lead to high CPU and high memory as well, right? How it can lead to, right? For example, there is a slow storage. If the storage is slow, then the query has to execute longer. If the query is executing longer, then the CPUs will be pegged up, the CPU will be spiking up, and the amount of memory it requires to execute the query also would be more, right? So for that reason, we need to have proper storage. Storage is very important in our systems, right? Make sure, and also you'll have to have the data and log files in a separate disk is recommended, right? So I have seen like many people are still using the same storage, or few of them are using a different storage, which is very good to optimal the performance, right? So because we frequently access the log and data file to access our data, right? So to write into the transaction log file, and we access data file for read and write operations, right? So if you have a same storage, there are chances that because of one, it impacts the other, right? Because of the transaction log file, it can impact the performance of writing into the data file or reading from the data file, right? So that impacts the performance. So it is always recommended to have a separate disk if possible, or mount point, whatever it is, right, for better performance. Also you will have to have a yeah, we will talk about the Tempdb. Okay, so network, so you should have a proper network, so that, for example, application team executed a query, right? So that is taking around 60 seconds to execute. I mean 60 seconds to get the response, right? So they got the response for in 60 seconds, right? So there, what is the guarantee? It is always an issue with the SQL, right? There is no guarantee. It is always issue at the SQL server, right? Let's say, for example, I was talking about the 3-layer architecture, right? Front end and application layer and the database layer. So if the application GUI, right? So whatever the framework that we have here, if you if you click on this, right, it has to connect to the database through a network and passing to the application, right? There are chances it is an issue with the application, or it can be an issue with the network, right? It can be issue with the network, right? It took almost 50 seconds, or let's say 30 seconds, to reach to the SQL and executed in only 1 second, and it is traversed back to the application in 29 seconds, right? So how much time it actually execute on the SQL is only 1 second, right? So if you capture some traces, right? So extend events or profiler will get to know what time the query is triggered and what time the query is actually executed on the CPU, right? So we might not see what time actually triggered from the application. At least we'll see that what time is executed at the SQL server. How much time it is executed at the SQL server side, we can identify by capturing extended events or profiler, or even few certain DMVs. That we will talk that later. For now, just understand, if there are chances that there is a network latency between application and the SQL server can cause this slowness, right? So make sure that the network bandwidth is good, right? Not only that, right? So network bandwidth, for example, let's say you have a high availability, always on, right? So you have a primary and secondary. What if the network is slow between the primary and secondary, and whatever data which primary is sending, secondary is not receiving on time, right? So then if there is a network latency between, then there are other issues, right? So the transaction log will not be truncated, and you will see that high logs and queue, read queue, whatever it is, right? So we will talk that in always on performance, maybe one of the sessions at end. So we will discuss those, right? So I'll show you that as well, right? For now, understand that if there is a network latency, that impacts the slowness, that impacts the performance, right? So in this what we can validate, right? We can validate this is an actual issue or issue with the workload. If it is an issue with the specific query, then that is something that we as a SQL DBA team or performance team, we can validate, we can check, right? So if there is a query is intensive query, then we can validate and we can recommend. Memory configuration, right? Let's say, for example, you have not properly configured, but you have enough memory available on the system. You as a DBA or SQL side not configured properly. That is something that we can validate. But if system needs more memory, or if the system needs more CPU, that is where we'll have to inform the system team or the server team to add more resources, or we ask the application team to reduce their workload, or even we can ask them to use connection pooling, right? We will talk about the connection pool later during connectivity. I mean, some troubleshooting with respect to session timeout or query timeout. So we will talk that, but understand, like we can ask them to use connection pooling. That can also reduce the number of connections spawning at the same time, right? So that is also we can validate. And this subsystem, we can identify if there is if the disk is poor or if the disk is good enough to handle your workload, right? So that is something that we can validate. So network also we can check the performance monitor, right? So performance monitor we can validate, and we cannot do much with respect to networking, right? So we can ask server team to look into that. Some configurations at the SQL layer, right? SQL layer, some configurations are very important, right? What are all? Let's say, for example, the first point that I mentioned, because this is very important, SQLs are a version and patching level. Let's say I have worked on a few scenarios, few issues. One issue was there is some memory clerk, right? So I will talk about the memory clerks. There is some memory area. Let's say, for example, that was taking up all the memory. That was eating up all the memory of around, I have configured around 100 GB memory to SQL Server. Around 50 GB of memory is taking using that some memory area in the SQL Server, right? Memory, I'll mention that clerk. Don't worry about what is this class. We will talk that in detail. Memory architecture and memory troubleshooting, right? 50 GB it is taking. And let's say, for example, this memory clerk is a query execution, right? So query is executing and it is taking up 50 GB of memory. As soon as the query is completed, the memory has to be released back to the SQL Server. But that was not happening. that was that was not happening. So sorry, I have a cough. Like that is the reason I just have to mute myself and do that. Excuse for that. Okay, so 50 GB of memory that I have, I mean, for this particular memory execution. And as soon as the query completes its execution, the memory has to be released back to the SQL Server. But that is not happening, right? So because of this, whatever queries which are coming in or whatever the workload that I have, and remaining 50 GB is not sufficient because this is not releasing the memory, right? Further checking, right? Further checking, we notice there is one KB, right? So knowledge base or KB, Microsoft has released, right? So it's a service pack or cumulative update, whatever the update is, that address this issue, that address the issue of this particular memory utilization, right? After applying that, and we have to definitely, the SQL services will be restarted, right? As soon as this patch is applied, the SQL resources, the SQL service will get restarted. So after applying the patch, right? So thus, after applying the patch, then this issue is fixed. The issue was fixed. So what I mean, there are likewise, there are many issues that I have noticed. If you are using any legacy systems, right? I mean, for example, if you are not on the latest version of the SQL Server, and if you're using 2016, for example, 2016, we have a service pack we had in 2016. Starting from 2017, we start releasing any of the new service packs. We are using, or Microsoft is releasing only cumulative updates, right? So cumulative updates that they are releasing, not the service packs, right? So patch level is important. If it is any latest service pack, or at least n minus one, n is nothing but the latest cumulative update, minus one is nothing but the previous cumulative update, you should have to have applied, so that if there is any known issues or any bug or anything, it will be fixed, right? So along with the patch, Microsoft releases this KB article, right? So KB is nothing but a knowledge base. And if you get some time, so read through that, whatever patch that you apply. Let's say, for example, I'm applying a security patch, um, something KB, whatever the security patch that I'm applying. For that security patch, you will have the knowledge base article or white paper, we call it as, and read through that white paper, and you will understand what are all bug fixes that KB has fixed, right? What are all bug fixes that KB releases to fix those issues, right? So that is important to know the configuration, right? How many of you know this? So majority of the people, or so most of us like might have enabled as part of our post installation configuration. All right, if you have installed SQL Server and there are many people or many application or users or the customers, they are using this feature, right? Can anyone tell me what is this, or if you are aware of? None of us used, or or don't know how to explain. Anything should be fine, right? At least you heard or used or not. No? Mm, okay, fine. So
I
let's.
think it will be in user,
Hmm.
right? It will be in user right assignment, like in that
What is
something like
user? Yeah, yeah. So what is
and
user right as?
security.
Correct. Yeah, security wise, right? So what is this? What do you mean? User right assignment. I mean, have you ever enabled this, or have you heard instant file initialization?
Right now, like I have no idea about this, but recently, like previous week, I something like my manager wants me to enable it. Like he
Hmm,
guided me,
hmm,
so I've done that. Like
hmm,
I've done using an SSMS. Like I've right clicked on it and I've gone through these properties and I've seen that installation, instant file installation, something is off or something. Then I've enabled it on and then I restarted this server.
hmm. Okay.
Something like that I have done, but like I have had like little idea about this, but I'm not sure about this instant file installation uses.
Okay, sure, no problem. Anyone else wanted to give a try? Or if you have heard, this is important, right? For example, let's say your let's say that your just taking a simple example, you are creating a database, right? So if you are creating a database and with anything, right? So it can be 1 GB or it can be 10 GB, whatever it is. So you are creating a database with 10 GB. It's an empty database, right? So let's say if you're creating a database and it is taking some time because it has to allocate the space for this database, right? So it takes some time. It can be a 1 minute or it can be 10 minutes to create the database. I mean, it can be more or less as well, right? I'm just giving an example. It is taking some time. This behavior is depending on this feature, right? Also, second thing, let's say you have an auto growth enabled at the database level. So if you have an auto growth enabled at the database level, as soon as it reaches the limit, the the file has to extend, right? So based on auto growth value that I defined, right? The file will be expanded. This expanding sometimes can delay the performance as well, right? Degrade the performance as well, because every time whenever it reaches the limit, it has to keep growing, right? That expansion, the disk expansion can be delayed. If that is delayed, then whatever queries which are coming in, it has to wait, right? So the database has to be, it has to wait for this expansion or the file expanding, right? So it has to wait. This also depending on this feature, right? So this also depending on this feature. And sometimes you are restoring the database, right? So while restoring, you have a, let's say for example, 1 TB of database or 100 GB of database, just simple example, and you want to restore the database at SQL Server side, and you are restoring, and restoration itself is taking time, right? Restoration itself is taking time. This feature can be an issue, right? So instant file initialization, if you don't enable, or if you enable that instant file initialization, all these operations that I was talking, right? Creating a database or auto growth, expanding the disk file size, or even the restoration would be improved or faster. How? I'll let you know what is that instant file initialization is, right? For example, if you just create a database, what will happen? By default, it creates two files. One is MDF, LDF, and I'm talking the instance file initialization is not applicable for log file, right? I believe starting from SQL 2022, I haven't tested, but I will have to validate. Starting from SQL 2022, we have new feature which applies instant file initialization for transactional log file as well, right? So instant file initialization is for data file up to 2022. So, but SQL starting from 2012, 2022. So the LDF file also. Now, let's say you have to create a database, right? What it will do. So first it creates an MDF file, right? So if as soon as I create a data file, the file will be created. Once the file will be created, so what it will do, it will start zeroing the file, right? So it will start zeroing the file, the initial file creation, right? It will start zeroing the complete file so that whenever the operation is required the file, this zeroing will be overwritten with the actual data, right? So the initially it will be zeroing the complete file, 000, complete zeroing the file. This zeroing file is the time consuming, right? Why I require to, uh, so zeroing the file, right? So if I zeroing the file, it is taking time to perform this zeroing. That is the reason as soon as you create the file, and if you go back to the what we call data file location, you will see the file exists, but the operation would not be completed. The reason in backend, it start zeroing the file. By applying the instant file initialization, we are actually skipping zeroing, right? We are actually skipping the zeroing file. As soon as I create, okay, this is my file. 1 second. Okay, sorry. So as soon as it creates, right? So I don't want to, I don't want to zeroing the file, right? I just wanted to create a file. That's it, right? It is skipping the zeroing of the file. At the same time, expanding the storage, expanding the data file. So while expanding, so let's say you are expanding 1 GB of the file. So before it is actually using the file, so this as soon as it expand, it will keep zeroing the file, right? So it will keep zeroing the file. As soon as this is zeroing completed, then it will start writing into the file, right? By enabling this instant file initialization, we are skipping this zeroing while expanding. So the same logic for restoration. So restoration, you might see the data file will be created initially, right? While restoring, so as soon as it is created, it will zeroing the file before actually restore is started. It will zeroing the file and it will overwrite the file with the data or data pages that we have in the backup, right? So that is the reason it will keep adding, I mean, it will, the time it takes to zeroing and writing into the file, it is a time consuming. To avoid that, we will have instant file initialization enabled, right? So if you, uh, as you mentioned, right, Chandu, like, so you cannot do that from the instance wide or SQL server side, right? So this is the security update, security level. You'll have to update that, right? So if I go back to the local security policies, right? So we have something called Windows R, right? So secpol.msc, right? Or local security policies, right? So if you type you security policies, right? You should see what happened to this local. Okay, I think my system request reboot. I'll do that later. Uh, right. So if you go here, security. Mm, fine. So if you just right click and run and secpol.msc, right? So this will open local security policies, right? If you just type that local security policies here, local security policy from here, and you will get the local security policies, the same thing here, right? So you will go to the local policies and user right assignment, right? You have something called user right assignment, perform volume maintenance task, right? So perform volume maintenance task is something that you will have to add, right? So perform volume maintenance task and double click, and you will have to add the service account here, add user group, and you will have to add the service account here. From here, you will have to add, and you will have to restart the SQL instance to affect the changes, right? So to affect the changes, right? So to affect the changes, how to get the service account? So there are different ways that we get the service account. Which SQL service is currently running? One way is configuration manager. Go to the properties. Second one is services.msc. Go to the properties, right? What if you are opening SSMS from a remote computer where you don't have a RDP access, or you cannot, so open services.msc or configuration manager. I will show you how to get the service account, right? We have a DMV called select star from sys.dm underscore server services, right? So this DMV, if you execute, it gives the service account of the servers, right? So whatever the SQL services that I am using, right? So even if you have a full text or whatever the services that we have, you will get this service account information here, right? So this is the service account that I have. This is the file path that I have, right? So instant file initialization is enabled or not, right? So you will see that instant file initialization is enabled, right? So obviously it is not for SQL agent, right? So it is not for SQL agent, it is for SQL services, right? So basically I have not added the service account in the local security policies. That is the reason it shows no, but that doesn't require the service account, right? Sorry. Majority of the things, right? So um, in the organization level, the service account would be same. So it will be either GMSA or group managed service account, or it is a domain account. That can be anything. That would be same. So you will see the same as instant file initialization, right? So instant file initialization is enabled, and this is the service account that you will have to add at the SQL at the local security policies, right? So that is the advantage of instant file initialization. But log file, we still have the same method or mechanism to write into the log file. It first zeroing the file, right? It first zeroing the file, then write into the file. So that is the reason some initially, I mean, some organization, it is not applicable to every company. It all depends on, so it changes. In my organization, at least, we enable the initial size of the file, we enable, and we don't enable the auto growth, right? So auto growth we don't enable. There are some performance issues, and one of the performance is while zeroing, right? So anyway, like, we also enable that instant file initialization, but at least for the log file also we enable that. For example, we estimate, right? So how much file size should be. Let's say, for example, data file size is 100 GB. The rough estimation is half of the data file, 5 GB for log file. We enable 50 GB, sorry, 50 GB log file, and we don't enable the auto growth, so that the zeroing would not be an issue here, right? This 50 GB will be reutilized based on the workload that we have. This all depends on the different organization, or the differs in different organization, right? So add SQL account to perform volume maintenance task in local security policies and restart the SQL services, right? So that is the reason we enable. Uh, I believe this is, we all know, lock pages in memory. So can anyone give me an outline, like what is this LPM, lock pages in memory? We will talk in detail or more about lock pages in memory in our memory, so architecture or troubleshooting, so that you will understand better, or so you will have a clear understanding. Uh, Anyone wants to talk about lock pages in memory? What is that? And have you ever heard what is that lock pages in memory? I'm sure like you might have heard, but I'm wondering like why no one is talking. Or if you have not heard, that's absolutely fine. Like you can say no. Okay. Fine. I assume you have not used, but let's see. So log pages in memory. Mm, okay. Okay. For example, this is your SQL Server. Okay. Before we talk about the log pages in memory, I will cover here. This is your SQL Server, right? Now I have two major things in SQL Server is main memory. I mean memory wise, right? I am talking min memory and max server memory. Can anyone tell me these two? We all know that what is min server memory and max server memory is, right? What are these two? And why we require min server memory and max server memory? Let's say I have 10 GB of memory on this system, right? Windows operating system. And I have allocated 8 GB to SQL Server. And let's say, for example, 8 GB for max server memory, 1 GB for SQL min server memory, right? Can anyone tell me what are these two? Right? So it should be interactive. Otherwise, I don't know whether you are.
Yeah, I'm trying to answer, but my son is crying. I'm sorry. That's why I was quiet.
No problem. So at least like if you have any
Yeah,
idea.
I
So
am here. I'm here, but my son is bothered. That's why I was just not answering or saying anything.
No problem. No problem. Sure. Yeah. No worries. So I'm yeah. No problem.
For the log page in memory, it's a Microsoft Windows operation system. Is allow for to use a SQL Server to use the RAM, right? Physical memory.
So what is
for
that?
more efficiently.
Memory?
I'm sorry.
And no, I'll just trying to understand, right? So you mentioned that Microsoft, uh, like given, like what exactly this benefit? I mean, what is this feature that we have?
What my understanding is for the log page in memory. That's a window operating system that allows SQL Server to use the physical memory RAM more efficiently.
Yes.
If we enable the SQL Server account, service account. That's what I understand.
Correct. You're in line, but anything you wanted to add or elaborate, like how or anything, right? So how it will utilize the memory in efficiently, how it utilizes the memory efficiently, right? So you are correct, but just few corrections, I'll correct that. If you can add anything or if anyone wants to add anything, would be fine.
Yeah,
Or at least, yeah, sure.
Generally we will allocate 10% memory to Windows OS, right?
Okay.
You know what, in order to work efficiently, we'll segregate memory to Windows OS and SQL OS.
Correct. Right.
Otherwise,
So
without allocating sufficient memory to Windows OS, we cannot able to work further, right?
Correct. But how this is impacting that behavior, log pages in memory or anything is
That
relevant?
help, yeah. Like to ensure like any critical database remain in memory, reducing like a disk IO, improving overall for the database performance.
So you mean
yes.
that if you don't enable these log pages in memory, that
No, when we enable it.
correct. So we enable it. For
Mhm.
example, if I don't enable these log pages in memory, so you mean that we don't, I mean, SQL Server doesn't manages memory efficiently?
Yeah, yes, it can manage.
It can or cannot?
It can manage.
It can manage. Then what is the advantage with this? Any thought? Okay, let's go one by one. So can any of you tell me what are these two? So if you understand these two, the behavior, so it is easy to understand the log pages in memory.
Actually, you know what? In previous classes, you told right while updating query, lock manager will put some locks in for some pages in buffer full in order to perform in order to load those data files from physical drive to it will take time, right? That's why we need some minimum space in
Memory.
yeah.
Okay. So what is that? Min server or back server?
Min
Min server. Okay. What is this Mac server?
max server means previously I told you right. You know what? For maximum, in order to work perform Windows OS and SQL OS, we need to give maximum memory. You know what? SQLs are consuming more memory. It is consuming more memory in compared to other applications. You told right. Some threads will occur separately for SQL server in order to give threads to some other applications. In our DB server, majority priority will give for SQL server. That's why we'll give more memory to SQL server.
It's simple thing, right? For example, let's say I have memory. If I go to the properties, right? If I right click and go to the properties of SQL and I go to memory. So this is what like I have, right? Min memory is 0 now. Minimum server memory. Max memory is around 2.4 gigs, right? 2400, 2450 MB. It's around 2.2 or 2.3 gigs memory that I have allocated to SQL Server, right? So this is my configuration is currently. Now let's say I have 1024 GB, right? So it's a 1 GB that I'm allocating as a min server memory, right? So current min server memory is
Yeah, actually, Chandu, you know what? For in SQL server, some background process will run, right? For that, we need min memory.
Okay.
You know what? For background session, we need to allocate compulsory that min memory, right?
So not only background, right? Background definitely is required memory. So how about the other threads, right? Other execution workload and all, everything is required memory.
Yeah.
Mm.
Yeah, I'm talking about regarding min memory.
Okay. Yeah. That is not actually true, right? So min memory, I'll tell you. So min memory, let's say for example, if we give it 1 GB of memory for SQL Server, right? So you restarted the SQL instance. Okay, at least this, so let's go with this. You restarted the SQL instance, right? So as soon as you restart the SQL instance, so how much memory it can consume? Like, is it that whatever memory that we allocated in the 1 GB of memory, or is it consuming a different memory that we have? Suppose if I allocate 1 GB memory to SQL as a min server memory, 8 GB to max server memory, and you are restarting the SQL. Okay. Okay, fine. So we are restarting the SQL Server, right? So this memory, whatever memory that we allocated, either it is a 1 GB memory or it's a 8 GB memory. So this is entire memory to have this workload completed, right? So for the SQL Server workload, it can be data pages or it can be anything in the memory will be utilized, right? It can be a query execution or it can be background process, or it can be a thread, whatever, everything will be utilized within this, right? 1 GB is the minimum memory that we allocate to the SQL Server. 8 GB is the max memory. So this entire memory is utilized by the SQL server based on the workload that we have. Let's say if you want to add, so if you want to process with a 1 GB of data pages, right? So that will be fit into the memory, right? So if I proceed with 6 GB of data, it will be fit into the memory, right? So, and you have some queries which require memory, and those queries will be utilized the memory what we have allocated, right? So now this memory which SQL Server uses is to perform its process, right? It can be a query execution, or it can be compilations, or it can be page cache, or it can be log cache. It can be anything within the SQL Server. It will be utilized the memory that we have allocated to the SQL Server, right? So that is the memory usage for SQL Server. Now, what is this mean server memory is you started the SQL service. So if you start the SQL service, though we have given 1 GB of memory, SQL Server is not going to take. I mean, it is not that it will not going to take. There are chances it might take, but that is a use cases, right? Based on the workload that we have. But it no need to take the memory that we have allocated. For example, let's say you have allocated 8 GB as bin server memory and 8 GB as max server memory. So if you start the SQL service, it is not that it will use this 8 GB as a min server memory. The minimum memory it is required to start. It can be either 500 MB or it can be either 1 MB, right? So it takes that minimum memory to start the SQL service. It will start the service. It will start the service, right? Now, this will go ahead and increase the memory utilization based on the need, right? That is the reason we call it as a dynamic memory allocation, right? So in SQL Server, it is a dynamic memory allocation. So after 500 MB, after initial, initial configuration, it will start increasing the memory usage. Let's say you have a huge query or the huge workload, which requires 1 GB of pages to be loaded into the memory, right? You are executing a query. It needs 1 GB of data. This 1 GB, it will load into the memory, right? So all these 1 GB of pages, it will load into the memory. Now this 500 MB will be increased to 1.5 GB, right? 1 GB is for the new data or data pages. 500 MB is already utilized during the initial startup. Now another query is coming in and it needs around 4 GB of data, right? Then this will be dynamically increasing to around 4 plus 1.5, 5.5 GB of data, right? So 5.5 GB of data, it will be increased, right? So likewise, it will be dynamically allocating, right? So the min server memory is the just a configuration, right? We are not, I'll tell you what is the advantage, right? So till what time it will grow, right? So till what time it will grow? The maximum that we allocated to the SQL Server, right? 8 GB as the max that we allocated. So suppose some other queries coming in, it needs 10 GB of data, right? I have already allocated 5.5 GB, right? Now, if I need 10 GB, what will happen? Whatever data that we have allocated, it will be go ahead and trim that memory by the lazy writer, and it will allow other pages, right? So it's max like 7 or 8 GB. It will allow other pages to accommodate, right? Remaining has to be waited, right? The remaining has to wait the memory to be available. Now, I told you, right? So the lazy writer will start trimming the memory. Let's say you have memory and lazy writer start removing the memory, cutting down the memory. So what point the lazy writer can trim the memory is depending on the main server memory. This is the base, right? When there is a memory pressure, it can be internal or external, right? So it can be internal or external. Even external, let's say there is a some other application, operating system level, we require more memory. So if operating system level we require more memory, then SQL has to release the memory. SQL, I told you, right? SQL will receive a notification from external notification and it sends all its memory usage, right? So buffer pool memory also will be reduced by the lazy writer. So the amount of memory will be reduced. It will start reducing the memory up to the min memory that we have, right? Up to the min memory that we have, it will start reducing the memory, right? So beyond this min server memory, the memory will not be trimmed because SQL has to sustain, right? To maintain or sustain the SQL service, we require some amount of memory. That is the min server memory it uses to handle the SQL services, right? So instead of terminating the SQL service, it will be maintaining this min memory so that it will not go below this min memory configuration, right? So that is the min memory and max memory. Max memory is the maximum amount of memory SQL server can utilize. Min memory is minimum memory with SQL server. If there is a memory pressure, either it is can be internal or external memory pressure, what is the minimum memory SQL server can cut down its memory to? Cut down its memory up to, right? If there is a memory pressure, it has to reduce the memory, right? So what point it will reduce is your min server memory. It will reduce. Now, what is the advantage of using log pages in memory based on this, right? So log pages in memory, what it has, the name itself is telling that the memory will be locked. What does it mean by locked? If SQL Server is growing, right? When let's say this is an external memory pressure. So what will happen to the external memory pressure? This is an operating system. Now let's see. I open so many panes. So let's say this is your operating system. This is your operating system. This is your operating system. You have a 24 GB of memory, right? Memory. Now you have a SQL server. You have some other application, either it can be a notepad or it can be PowerShell, it can be Power BI, whatever application it is, right? So you have SQL, Power BI, notepad. Now all are using some resources, right? Let's say for example, SQL Server is using around 20 GB of memory that we have allocated 20 GB, right? So now Windows operating system doesn't have this 20 GB I have allocated. Just simple calculation, right? So don't quote that like, so out of 24 that I have allocated 20 GB and all. Just an example I'm showing. 24 GB, 20 GB SQL is using currently. Now there is an external memory pressure, right? So we require Windows operating system. So Power BI using around 2 GB. It can be Notepad or it can be anything, the application, that PowerShell or whatever it is, right? So 23 GB is utilized by these three applications and remaining 1 GB I have at the Windows operating system level, right? Operating system, I have only 1 GB of memory. Now, so Windows operating system is not sustaining because of 1 GB. It requires more memory. So if it needs more memory, what it does, it checks which are the top memory consumers, right? It detects SQL is the top resource consumer because Windows can see the memory what we have allocated, right? If you go task manager, details, right? So whatever the memory that we have, for example, let's say you have SQL, right? For example, you have a SQL server, right? Whatever memory that we have allocated, we see here, right? The same way, you Windows operating system can see whatever memory that we have allocated for SQL Server. So it send a notification to the SQL Server stating that reduce your memory, cut down your memory so that I will process my workload, right? So cut down your memory, I will process my workload. So SQL Server will start reducing the memory, right? Now, what why Windows operating system decides my memory utilization, right? If I cut down the memory, it impacts the Windows performance. Instead of that, why don't I remove or ask these two applications or other applications to reduce its memory? Because if I reduce my SQL Server memory, that impacts the performance of our queries, right? Users. That is an impacting application, right? So what I can do, I can enable log pages in memory. LPM. Log pages in memory, if you enable, then Windows cannot see the memory that we allocated to the SQL Server, right? Whatever memory that we allocated, 20 GB, Windows cannot see, right? What Windows can see only certain shared memory, right? Only some part of memory can be visible, right? Whatever memory that we have allocated, it will not be visible to the Windows operating system. So that is the reason sometimes, I don't know how many of you noticed, if you go to the task manager and checking the SQL memory is not optimal, not recommended, because if you enable the log pages in memory, task manager, you cannot see the memory allocated for the SQL service process. What is that? So in this task manager, you cannot see the memory allocated for SQL process if you enable log pages in memory, right? So log pages in memory enabled, and you cannot see the entire memory that is utilized by the SQL Server from the task manager, right? So I will talk in a detailed session like how to check what is the memory and all. So for now, understand that log pages in memory is helpful for the SQL Server. I mean, so it will not visible, whatever memory we allocated to the SQL Server, it will not be visible to the SQL Server. So now instead of 20 GB, what is visibility is only some portion of the memory. Let's say, for example, shared memory. Shared is nothing but shared across multiple processes, multiple applications, or even multiple SQL services, right? Executables, some shared memory can be visible to the Windows operating system. So that memory only visible. It can be 1 GB or it can be 2 GB, right? It can be anything very less you will see from the task manager, or Windows can see the memory, right? So if you enable log pages in memory, how to enable is, again, you have here local security policies, log pages in memory. You have to enable the memory here, right? So in the memory discussion, I will talk in details. I don't want to discuss now. Right. So after enabling, I'll show you that how this log pages and all will work. Right. This is the LPM. So hope at least you understand that instant file initialization, log pages in memory, whatever that min server and max server memory, right? And Tempdb configuration, right? So this is also very important. We will have a detailed session. Don't worry about Tempdb, that I'm not going to cover here. I will have a detailed session how the Tempdb works and what are the workload that we have and all. High level, understand that Tempdb is very crucial with respect to the performance and the SQL for SQL Server as well. Right. So as we all know, Tempdb is a global database, right? Whatever the global database is nothing but whatever queries which are executing, it will be using the Tempdb. So either it can be direct or indirect, it will be using. For example, direct as in you are creating a temporary table, right? CTE or any temporary tables, it will be using the temporary or Tempdb. So indirect is, for example, let's say you are creating a snapshot, database snapshot, or you are executing re-indexing, right? That you are doing some sort, right? Order by or any sort that you are doing. So that all will be using Tempdb for its operations, right? For its internal uses, right? So we will talk that in detail in Tempdb thing, right? So Tempdb bottleneck or Tempdb utilization or performance of Tempdb utilization. But remember, Tempdb also better to have a separate storage than your user databases because Tempdb is highly operational, right? So every time that you need some data, so you will have to go ahead and access the database Tempdb data and log file as well. So it is highly operational and it can impact the other data files performance issues as well, right? You will have to have Tempdb configured. So in a high level, I'll just mention that um, Tempdb. So usually the old recommendations, right? We have a Tempdb and the number of Tempdb data files should be based on number of Tempdb, number of CPUs that we have, right? The reason we have, right? So we have some internal system pages, right? GAM, PFS, SGAM, right? Global allocation map, page free space, shared global allocation map, right? So whatever the pages that we have, Tempdb, while accessing, while creating, or let's say, for example, if it needs to create a table, right? If it has to have the table created, then it has to access the pages, right? So system pages, and it is frequently accessing the pages, right? If you have the same or less number of files, there are chances that the queries are trying to access the same file. So instead, what if you have split across multiple CPUs, right? Based on number of CPUs. Let's say, for example, you have 3 CPUs and you have 3 Tempdb files, right? The thread will try to access one file at a time, right? All threads will not try to access the same file. There are still chances like if you have a high number of CPUs and you cannot keep creating the number of files. Let's say you have 64 CPUs and you cannot keep creating 64 Tempdb files, right? So based on some logic that we will have to apply. We will talk that later. For now, understand Tempdb is a highly operational and which requires or better to have a separate storage to configure and number of Tempdb files based on number of CPU cores or CPUs, right? To reduce the contention of system pages. Tempdb configuration. We will talk the Tempdb contention in detail. Trace flags, right? So these are all not actually used. I mean, starting from 2016, I think SP2 or SP3, whatever, right? So these trace flags or even SP1, some CU, cumulative update, these trace flags are inbuilt in database engine, right? So while creating what we call so table, right? By default, it uses the mixed extent. right? That we all know, like while creating a table, that size, that table can fit into very few pages. So for that reason, initially it uses the mixed extent. Let's say, for example, mixed extent is nothing but 64 KB of 8 pages. 8 pages, right? So 8 pages. When you create a table, it can be it can fit in 1 page or 2 page, or it can be 5 pages, right? It can be anything. To avoid the entire extent, suppose if it allocated entire extent, what will happen? If it fit into only 2 pages, the remaining 6 pages will be wasted. To avoid that, SQL default behavior was, while creating a table, initially it uses the mixed extent, right? So it will not allocate a uniform extent, it will be using a mixed extent. So only uh, 8 pages can fit, 8 pages can be accommodated 8 different tables, right? So 8 different tables. That can be very intensive, right? For example, the table we are creating, it's very heavy transactions, right? We have small queries, right? It is creating and destroying, creating, destroying, creating, destroying. So small table, and it is keep accessing, right? So it keeps allocating mixed extent. So to allocate the mixed extent, you'll have to scan the PFS, page free space, right? You'll have to identify which page has a free space. I mean, which page is available in an extent, right? It is keep accessing that PFS page, right? So that is again an intensive operation, right? So to avoid that, we allocate this. We enable 1118 trace flag, so that every table, right? So even if it is a small transaction, anything, every table we allocate a uniform extent. We are not allocating mixed extent, so that we reduce the PFS or SGAM contention to allocate the pages, right? So that is where I don't think we have, starting from 2016, we don't have this feature. This we don't require this to be enabled. So this is the default behavior. And 1117, right? So whenever the auto growth happens, right? So let's say, for example, this is also default behavior. Now I have 3 files, right? So now I want to allocate space, right? So let's say this is 10 GB, this is 10 GB, this is 10 GB. Now I have allocated space. So in SQL Server, allocates threads, and this utilization of the auto growth is based on the available free space. For example, let's say this is 90% full. Example, this is 10% full, this is 10% full. So in SQL Server, everything should be round robin in a professional fill algorithm. So round robin, it should be go here, here, here fashion, right? If it is 90% full, this will never go. It will keep executing these two. Then what will happen? There is a imbalance while accessing the file, right? For that reason, what SQL Server does, while auto growth enable, right? So this will make sure that all the files will grow at the same pace, right? So same size, right? For example, let's say if this file is full, and even remaining files are not full, the size increment would be uniform. The size will be at the same size, right? Whatever based on the auto group that we enable. SQL Server auto groups all data files in the file group when one of the file is out of space, right? So even if the one file is out of space, all other files also will keep growing, right? Not needed starting from 2016. Earlier, so we used to have optimizer fixes. Optimizer fixes as in there are chances, right? It might be before 2014 SQL Server, where we have SQL Server 2014 new cardinality estimation. We will talk that in one query performance and tuning. So earlier, there are some optimizer fixes. The optimizer, right? So where we have this optimizer, right? Optimization thing, like that has some bugs. That has some bugs, issues, right? So that cannot be resolved. So Microsoft has released this trace flag along with some KB, along with some patch, KB, knowledge base, right? Along with some hotfix or cumulative update, they ask us to enable this trace flag. So after enabling this, right, after installing this KB, whatever fixes, it will be applied, but only applied after enabling these query optimizer fixes, right? So we have to enable this query optimizer fixes at the instance level so that if there is any optimizer bugs will be resolved using this optimizer fixes, right? Again, this is also not needed starting from 2014 SQL Server. But this is what to note. For example, if you have older versions, this might be helpful, right? Okay, so I have a few. This max memory I almost covered, right? So I'll stop here, right? So I know it is late, so I'll stop here, and I will cover these few, and then we'll go for weight statistics tomorrow, right? So what are the weight statistics, and when we call, so what it is waiting for, and if the query is taking longer, what we need to look into. I mean, that is not a query tuning again. So I'm just with respect to weights, right? Either the query is running or waiting for some resources, right? That needs to be isolated so that we'll understand the issue, right? For example, let's say the query is running and taking time, right? 10 minutes to execute. If the query is taking 10 minutes to execute, and we'll need to understand this 10 minutes is actually executing or waiting for some resources, right? Let's say, for example, 8 minutes, it is blocked, right? It is waiting for some lock, right? Then actually executed is 2 minutes. We need to understand why it is blocked for 8 minutes, right? That is where we need to understand further in our tomorrow's sessions, right? So weight statistics and what are the types of weights that we have, right? So we have these two, like I'll explain this in a high level in tomorrow's first a few minutes. Then we'll go with weight statistics and we'll understand, like, so what are the weight types, what are the weight that we have, right? So any questions?
Yeah, as we mentioned in previous one, minimum memory and maximum memory, is there any standard percentage that we do we need to maintain for that, for SQL Server in
No.
total?
No. So you mean that min server memory and max server memory?
Yes.
Yeah, no. So there is no as such. Like I have seen people are using 0 as min server memory and max 0 as min server memory and max memory as per, like, so 80% of the overall system memory. So that should be fine, right? So, but if you enable lock pages in memory, min server memory is not nothing, right? So min server memory you can ignore. If you don't enable lock pages in memory, uh, that is where we will have to analyze. There is no standard process that you will have to have this 20% or something. But if you don't enable the lock pages in memory, I have seen people, they are using the same as max error memory. For example, 10 GB of max error memory, and they configure 10 GB as min server memory as well. The same configuration. So there is no standard process that you'll have to follow. You can, based on the workload, but recommended is to use this lock pages in memory so that if there is any memory pressure, it will not start trimming or reducing the memory. That needs
Okay.
a restart of the sequence.
Okay. So like basically I have seen minimum memory in my one of my servers as a 0. So that is what I got confused.
Yeah, it will calculate internally and it will be it will consider that means our own memory.
So
And
basically you are saying this log pages memory should be enabled. It will be like as a good practice, right?
it's recommended, correct.
Okay.
Sorry. So any questions? Yeah, it is recommended to enable so that if there is any external memory pressure, Windows will not start trimming the memory for SQL Server. All right. I see people are start dropping off. Any questions so that we can talk? Okay, cool. I hope it's clear. If you have anything, we can talk maybe in tomorrow's session. But tomorrow we'll complete this and then we'll go to weight statistics, right? Cool. Thank you. See you tomorrow then. Bye.
Okay. Thank you.
Thank you.